Hello students, welcome to Legrange's mean value theorem, geometrical representation of Legrange's mean value theorem, another form of a Legrange's mean value theorem, and we will discuss one problem. So let's get started. The statement of the Legrange's mean value theorem is let f AB2R domain is closed interval A to B or codomain is real number set B, be a mapping such that there are two conditions for LMVT. The first condition is f is continuous on closed interval a comma b. The function is continuous on closed interval a comma b. Number two condition is f is differentiable or derivable on open interval a comma b. There is no third condition. Then there exists at least one real number C belongs to open interval a comma b such that f dash of C which is equals to f of b minus f of a divided by b minus a. This is the theorem statement of Lagrange's mean value theorem. Okay, so now the next we will discuss about geometrical representation of a Lagrange's mean value theorem. Geometrical representation of Lagrange's mean value theorem. So geometrically we'll discuss. Let us suppose this is my x-axis, this is my y-axis. Suppose that y-axis, this is my y-axis, this is my x-axis. Suppose the curve is like this. Here the point is A on x-axis. Suppose this end point is B. This distance is f of A and this distance is f of B, which means here the point capital A whose coordinates are A comma function of A and B is here end point whose coordinates are B comma f of B. Now from this figure you can join these two coordinates, these 2 points A and B, join this line. Okay, on the curve, suppose there is a point here. Suppose the point is C. I will be write later. Here suppose the point is here C. The point for the point C coordinates are capital C comma f of C. So draw a tangent line at this point. The tangent line is like this. This is the tangent line. Okay, the next step, if you observe here, this coordinates of this point C, suppose C, capital C, small c comma f of C coordinates. So this is our tangent line at tangent line at capital C comma f of C, or you can say simply tangent line or f dash of C. You can say f dash of C. Okay, this is f dash of C also you can say. If you observe from the figure here, f dash of C means slope of a tangent line at C. And what is this AB? It's a straight line. The slope of this straight line is, for 2 points are given, y2 minus y1 by x2 minus x1, which means the slope of this line or chord is f of b minus f of a by b minus a. So from this figure we can understand here lines are parallel. Tangent line as well as AB are parallel. If lines are parallel, slopes are same. Slope means slope of tangent line is f dash of C and slope of chord AB is fb minus f of a by b minus a. This is nothing but geometrical representation. So here we can write here. So let f AB2R be a mapping. Let f AB2R be a mapping. Which means function such that so satisfies conditions, two conditions, or I can say here conditions of Lagrange's mean value theorem. Then the graph, we can say y equal to f of x. Then the graph y equal to f of x. First condition is it is continuous. If you see the figure, it is continuous. It is continuous from the point capital A to capital B, which means capital A small a to f of a to capital B of small b comma f of b. Next, between a comma b, we can observe between a comma b, okay, the curve has the curve or y equal to f of x or this given curve, the curve has a unique tangent, a unique tangent, a unique tangent. So you can draw here, so tangent, so you can draw over here, draw overhead. So if you draw a tangent, it should be unique at every point from A to B or between A to B, from between A to B. Okay. So then, so there is no third condition. The result of Lagrange's mean value theorem is there exists at least one real number, or simply we can say there exists at least one real number. Directly I am writing C belongs to open interval. So here we need to take the interval is, so interval is a comma b, open interval a comma b, such that f dash of C, which is equals to f of b minus f of a divided by b minus a. So if you see left side and right side comparison, left side is slope of a tangent line at point C, right side is slope of a chord AB. So when 2 points are given, we know that very well. The rule is y2 minus y1 by x2 minus x1. So difference between y coordinates by difference between x coordinates. Slopes are equal. Now how do you write here? So that is slope of a tangent line at C is equal to slope of the chord or line, you can say, or chord here, chord AB. Hence the result. Now we'll discuss about another form of a Lagrange's mean value theorem. Another form. The statement I'm writing: let f a to a plus h to R be a mapping. R means real number set codomain. Be a mapping such that the first condition f is continuous on closed interval a to a plus h. Next condition, function is derivable or differentiable on open interval a comma a plus h. So afterwards there is no third condition. Then there exists at least one real number. So 0 less than theta less than 1, which means theta belongs to open interval 0 comma 1, such that f dash of a plus theta times h, which is equal to f of a plus h minus f of a whole divided by only h, because plus a minus a cancel out. Okay, after that, students, we'll discuss one problem. So the problem is show that v minus u divided by 1 plus v square, so it is less than tan inverse v minus tan inverse u, again less than v minus u divided by 1 plus u square, if 0 less than u less than v interval, and also deduce pi by 4 plus 3 by 25, which is less than tan inverse of 4 by 3 less than again pi by 4 plus sine, so it is 1 by 6. So we need to prove that v minus u by 1 plus v square less than tan inverse v minus tan inverse u less than v minus u by 1 plus v square if the condition is given 0 less than u less than v, and also deduce this inequality. To prove this result, proof. Okay, so what we do? So we need to apply Lagrange's mean value theorem here, but Lagrange's mean value theorem requires a function as well as interval. So interval is given in the question, the function is not given directly. So how do you choose the function? By the inspection only we need to choose the suitable function. First concentrate on this inequality. So here, so tan inverse v, tan inverse u. So let us suppose the function is tan inverse x by the inspection. Interval is here 0 less than u less than v, which means so u to v you can choose the interval. Now afterwards apply the conditions of Rolle's theorem, then okay, we can with the help of the theorem statement only we can deduce the result also. Here what we do, let us choose the suitable function. Let f of x equals to 1 tan inverse x, tan inverse x, inverse function. Let f of x equal to tan inverse x, suppose that like this. Now interval is, so I am writing here interval, closed interval u to v. So because as per interval the first value is less than the, okay, smaller than the second value. So already given we have 0 less than u less than v format only. Okay, now afterwards, so check the first condition of continuity. So clearly f is continuous, clearly f is continuous on closed interval u comma v. First condition of Lagrange's mean value theorem satisfied. Now differentiability. So which means what? First f of x equal to tan inverse x. So differentiate. Then what is f dash of x? F dash of x is 1 by 1 plus x square, derivative of tan inverse x, which means derivatives exist. So we can write here, therefore f is differentiable or derivable on open interval u comma v as per this problem. Okay, two conditions are satisfied. Now we need to okay, apply Lagrange's mean value theorem. We need to write. So conditions we can say conditions of Lagrange's mean value theorem are satisfied, are satisfied. Okay, so by Lagrange's mean value theorem there exist, okay, at least one real number, at least one real number, one real number, let us say real number is c, belongs to open interval u comma v, okay, such that the rule is, so f dash of c which is equal to f of b, f of b means f of v minus f of a means u divided by b minus a, which means v minus u, not u minus v, v minus u. What is f dash of c? If you go back previous page, we have f dash of x is this one. This is f dash of x. So plug in x equal to c, you will get f dash of c. F dash of c equal to 1 by 1 plus c square. The next step is here f dash of c means left side 1 by 1 plus c square. It is equal to f of v. F of v means what? Tan inverse of v minus, because our function is f of x equal to tan inverse x. So now plug in x equal to v, tan inverse v. Similarly, tan inverse u divided by v minus u. Okay, this here if you observe here there is a equality sign, so we cannot get directly. So we cannot prove directly so given result. So what we do here, so here what we do, tan inverse v minus tan inverse u divided by v minus u. So since to prove this result, since 0 less than u, so since we have given sorry. So since we have C belongs to open interval u comma v, which means u is less than C, less than v, which means there is a real number here. For suppose this is u, this is v, in between we have C is there in between. This could be writing u less than C, less than v, this format. Okay, I need to write 1 by 1 plus C square value here. I want, so in between this C value, so which I want to write like 1 by 1 plus C square, I want to change. For that, what we do, u less than C less than v is nothing but u square less than C square less than, so less than v square. If squaring the inequality, it does not change. For adding 1 for the inequality, it does not change. 1 plus C square less than 1 plus v square. Now I need reciprocal 1 by 1 plus C square. Now if you change the inequality, okay, 1 by 1 plus C square u square. So now if you change, if you take the reciprocal, inequality sign will change. So earlier it was less than, now it has become greater than. So 1 by 1 plus C square, again greater than. So something like here 1 by 1 plus here v square. Since for example you have here something like 4 less than, something like 5 less than 6, it is, take the reciprocal, 1 by 4 is more than, so 1 by 5 more than, so this is okay 1 by 6, 1 by 6. Is it clear? This is the way here. So 4 less than 5, 5 less than 6, if you take the reciprocal, so 1 by 4 greater than 1 by 5 greater than 1 by 6. The next step is, so 1 by 1 plus u square, so I can replace 1 by 1 plus C square from equation 2, that is tan inverse v minus tan inverse u, again more than 1 by 1 plus v square, since using number 2 equation. Okay, so after that, is it 2? Yes, equation number 2. So after that, so we have here down denominator also v minus u also there, divided by v minus u. Now I want the result here only tan inverse v minus tan inverse u. I have to remove denominator in the next step here. How to remove? Multiply by v minus u. So v minus u divided by 1 plus u square. Now here it is more than, here v minus u gets cancelled out. Tan inverse v minus tan inverse u, so which is again more than v minus u, you are multiplying numerator by 1 plus v square. After that, so here, so we have a result like this simply. So here 6 is, so we can say here less than, for example, okay, 7. 6 is more than, I can say here more than, example 6 is more than 7, okay, 7 is more than 8, for example, sorry, 6 is more than 5, for example, 5 is more than 4, for example. If you change the inequality, so this could be is, this could be is same as 4 less than 5 less than 6. This is same as 4 less than 5 less than 6. Similar pattern here, changing the inequality. So this term I am writing as a first term now, okay, which means v minus u divided by 1 plus v square, 1 plus v square is less than now. So this middle term becomes same, tan inverse v minus tan inverse u, which is again less than v minus u divided by 1 plus u square. Let us suppose this is number 3 equation. Okay, but actually this result is, first result is proved. If you look here, first result is v minus u by 1 plus v square. So this result is proved now, this result. But so we need to prove another result also. Deduce pi by 4 plus 3 by 25 plus tan inverse 4 by 3 less than pi by 4 plus 1 by 6. How do you prove this? If you look here, middle term, okay, we have here tan inverse 4 by 3, which means here there is a v, there is a u. I have to choose the suitable values for u and v in such a way I should get here pi by 4. Here pi by 4 number is there, 4 by 3 also. So by the inspection, let us take this v value 4 by 3. Take 4 by 3. This value put 1. This value tan inverse 1. Tan inverse 1 is 45. This pi by 4 you can transpose left side as well as right side, both side. Then here middle term will remains as tan inverse 4 by 3. This is the idea. By the inspection of this V value, we will choose A and B. A value V, so that is U and V. V is 4 by 3. U equal to here 1. Why 1 means I want tan inverse of 1 is pi by 4. For example, other angle is added here. Okay, pi by 6 or pi by 3 added. Depending upon angle, you need to choose the suitable value. Okay, let us prove this result by taking suitable U and V values. U and V. So here what I will do, so deduction I can say. Now I can say deduction. So put U equal to 1, V equal to 4 by 3 in equation number 3, and then simplify. Here numerator is V minus U, which means 4 by 3. 4 by 3 minus 1 divided by, okay, denominator 1 plus V square. So is it 1 plus V square? V square means 16 by 9, which is less than tan inverse V is there. V value 4 by 3 minus tan inverse of U. U means 1, less than again V minus U. 4 by 3 minus 1. 4 by 3 minus 1 divided by 1 plus U square means 1 square. Simplify this one. If you look here, denominator 3. 3 times 1, 3. 4 minus 3, 1 by 3 here, numerator. Here also 4 by 3 minus 1, 1 by 3. So numerator 1 by 3. What about denominator? 9 is coming here. 9 multiplied by 1, 9. 9 plus 16, 25. 25 by 9. Okay, so the next step will be, so I am writing here. So this value will be 1 by 3 divided by 25 by 9, which is less than tan inverse of angle 4 by 3 minus, this is tan inverse 1 is pi by 4, less than 1 by 3 divided by 1 plus 1 square is 2. After that, so this 9 is taking numerator, 3 is taking denominator. 3 times 3, 9. So 3 cancel out. So 3 by 25 left. So less than, okay, tan inverse. So we can say 4 by 3 minus pi by 4, again less than 1 by 6. After that, add pi by 4, okay, for the each term. So if you add pi by 4 for each term, so pi by 4 plus 3 by 25, which is less than tan inverse of angle 4 by 3, less than again pi by 4 plus 1 by 6. Hence the result.